Okay, we're looking at 4.2b corrections, and we got 1, angle E, 2, segment AB, 3, FG, and 4, 5, 6. Now, keep in mind, we are supposed to pay attention to this directions that we're only looking for side angle side, and if it's not side angle side, it's not enough information. So this is not enough info in number 4. In number 5, it's actually side angle side, because this is reflexive. And 6, we knew yesterday that this was side, 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 but according to our directions today, we got to say not enough info. Not enough info, NEI. Okay, as we go through. Now, when I'm talking about 7, I'm looking at not enough info. 8, I've got side, 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 but according to our rules, not enough info. 9, side, angle, side, congruence. The other thing that we got going is 11, side, angle, side, congruence. Not enough info, and not enough info. Now, keep in mind, all the things that were side, side, side yesterday were not enough info for side, angle, side today. Okay? We're just paying attention to our directions. That's it. In 13, segment JH. In 14, segment N, or excuse me, angle N. Are there any other questions on that? Now we're looking around at 15. Let's check these out, maybe, if it gets over there. We're asked to do a proof on these. Now, make sure when we're doing this that you recognize the importance of the picture and the given when you do this. Because students are always like, Bloom, how do you know? I look at the given, and in the given, I'm going to hide stuff. Do you see this? I just hid 2 angles right there, what I underlined there. What segment GK bisects angle JGM means is that JGK and MGK are congruent because of definition angle bisector. Now I have GK because of reflexive. Do you see the GK because of reflexive? Okay, as we go across there. So I have segment JGM. I have this because this angle and this angle because of the fact that we're working with angle bisector. And then I have GK, which is reflexive. Do you see side angle side here then? Okay, so when you wrote it, you had your given, you had your angles, definition of angle bisector. That might have been a new one for you, okay? But it kind of makes sense. It's what we did in chapter 1. I'm just revisiting it as we go through. And then we have segment GK, congruence of segment GK because of reflexive property, okay? Now, I'm asked all the time, Bloom, how do you know it's going to be side, 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 angle, 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 side? Because I'm including those today. And I'm like, really what it comes down to is what I'm provided in the problem. Look at what I've been able to prove. I was able to prove they gave me a side. I got an angle, and I had the other side. So I have 2 sides to make the angle. That's a side angle side situation. That's why I can say the 2 triangles are congruent because of side angle side. Okay? I'm not going to use anything else because nothing else fits the situation that I'm working with. Okay? And now I want to look at it as triangle congruence tools. Okay? I'm just looking at the situation. I'm determining which approach I should take, which tool should I grab? Side, 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 angle, or angle, angle, side. And then I make the decision and I go with it until I run into a wall that I can't. But most of the time, I realize, hey, it's going to work. That's why we do these triangles. Hey, how do you know this triangle is going to be congruent to this other one? That's why we do those. So you start realizing, oh, this is the type for this one and no others. Okay, so let's look at 16. In 16, I give you something new, but with something that we've done before. I just told you 2 segments bisect each other. Okay, normally when I tell you, well, it's the midpoint, It's M's the midpoint or something. And in this case, it would have been C's the midpoint. But I didn't tell you C was the midpoint. I decided to say it differently. I have segment bisectors. Okay, a segment bisector does the same thing as me saying, hey, C's the midpoint of both segments here. So AC is congruent to EC because they're mutual bisectors of each other. DC is congruent to BC because it's mutual bisectors of each other. So now I'm looking at this and I've got that situation. Okay, so I'm going to say something after that. I've got these bisectors and I spilled over on the other side on it. But I tried my best to be as neat as I could, but you know, with crayons in such a small spot, it was some pretty thick writing to try to get it done. But for those people that were able to attempt this at home, were you able to get this one? Okay, this one was kind of a little tricky because we haven't done it before, but it was kind of similar to some stuff we've done in the past. So if you just look up some of the definitions and get used to it, it'll be good during an assignment. But remember, after quiz and test, we should be ready for it. I'm going to quiz and test on stuff we've already covered. Okay, it's not going to be like, ooh, brand new stuff. No, it shouldn't be. And if it feels like brand new stuff, maybe perhaps we should change how we're approaching our class. Reread your notes. Make sure you're asking questions so it isn't seemingly new all the time. Now, keep in mind, in 16, this is a bow tie. So I've got to be talking about my vertical angles. And my vertical angles here are ACB and ECD. Okay, as I go through. And I just put little dots there because my board's been funky. My angle arc marks have been really all over the place. And then my final thing. Now look at what I have. I have a side, well actually two sides, that make the angle that's congruent. So I'm looking at a side angle side formation here to finish out my proof. And that's how I know that I'm done, because I have achieved my goal to prove two triangles congruent to each other using one of the four now. Today we're going to learn two more, four congruence triangle shortcuts. Now keep in mind as we're going, when you are looking at these, I'm actually giving you kind of a list of reasons you can use to prove triangles. And people are like, what do you mean a list? Well, we've used definition segment bisector. We've used vertical angles. We've used given, but you know that. That's pretty much almost a given to use given, right? And then we got definition of angle bisector, reflexive property. Remember, pay attention. I shouldn't say play along, but pay attention to what we're doing, because this is reasons for why I can do my steps. People are like, well, where are all these reasons? I'm exampling all the ones I'm going to use on the test in front of you every day. Okay, so let's do this next one. Got my given. Went real well. Investigate the diagram with the given. Please pay attention on this one. This one's unique compared to the other one because I've got those parallel. And at the same time, I've got these. Those are tick marks that prove, or not prove, but show that the segments are congruent. Those are two different markings. You need to be aware that just because I give you something that's parallel, it does not in any way, shape, or form means they're congruent unless they're marked like this one is. Okay, so keep that in mind. Now, with that said, because I have parallel, I got this angle and this angle congruent to each other because of alternate interior angles. Okay, and then I'm also looking at the idea that FK is reflexive. Okay, so that gives me side angle side to make these two triangles congruent. Do you see it? I got some head bobbles. That's good. That's good. You at home, if you're head bobbling, that's good too. The computer appreciates it. Okay, but keep in mind as we're going through here, I know right now how I want to write my proof. I got my given. I can talk about alternate interiors, reflexive, and now side angle side. So I got 4 steps as I go through. But that's how I go about setting these up. You know, it's like I'm doing a pre-write or, my rough draft when I look at my given and I break it down in my diagram. And then I start looking at what direction I'm going to go. Well, you do that in everything you do. I mean, if I was going to go on a trip, say to Banff, okay, first of all, I'd have to check out what country it's in. It's in Canada. Okay, and then I said, which direction is it? How long is it going to take? How much money do I need for gas? But more importantly, where do I want to enter Canada? Okay, or how do I want to go about getting there? So, and what points of interest do I want to do on the way? So I have to investigate all that. I'm going to go south to Canada. That's what I'm going to do. I'm just going to keep driving south until I get to Canada. Would just be a really wrong direction to go. So I have to have a plan. Okay, well, every time I do a proof, it's about me setting up a plan on things I know. If I don't know something, I should ask questions or look it up. So when I'm looking at this next one, I'm looking at what, 18? I've given you, once again, perpendiculars. Okay, segment AB is perpendicular CM, segment CM. Segment AB is also perpendicular to segment DB. So I've got these right triangles, right angles there. But I don't know the right angles right now. I just know I have two lines, or two segments in this case, two sets of segments that are perpendicular. And perpendicular lines make right angles. So I've got perpendicular lines make right angles. So I know DBM, and what I'm talking about is this angle, DBM, and this angle, CMA, are right angles by definition of perpendicular lines. I know that. And every time I'm giving that two segments or two lines are perpendicular, I got to do this, perpendicular lines, right angles, created right angles congruent dance, okay? It happens every time. There's always two lines. And the second line is I got to talk about my right angles being congruent, okay? And that's from chapter 2, all right angles are congruent. So now if I look at this, I've got, okay, I got those right angles, and then they've got this phrase, M is the midpoint. Oh, dude, I got this one down. I got definition of midpoint. That's in my back pocket, right? So I've got BM and MA are congruent because the definition segment midpoint, MDPT is midpoint. Me dropping all my vowels I got in an N, I guess. But now I look at my diagram again, and I've got it marked. So I've got a side, an angle, and a side. So I've got my triangles all congruent because of side angle, side congruence. So I'm good to go, right? I've got this thing, no problem. I just want to make sure you guys know, every time I do this, I look at the given, I look at my picture, I look at what's marked. If it's not marked, I mark it. Okay, as I go, I mark it to make it easier for me to see what I'm doing. And then I reread the given. I start writing my proof, and I have a pretty good idea of what I'm going to go and where I'm getting there. But you got to make sure you know the material. And again, that's because you got to reread, ask questions. Okay? And I got some people who want, dude, I don't want to be a study buddy. Trust me, it is way better to do it that way for the next 2 weeks than in a month from now go, Bloom, I don't get this stuff. And I was like, dude, we got like a chapter and a half left. Okay, we got to get this stuff. Okay, so make sure that you're focused in on it. Problem 19, the answer is 13. But you got to make sure you know that you're looking for distance formula. And if a strawberry is ripe, then it is red, is the converse. Okay, so we're doing a lot of review. We just reviewed in this one assignment, chapters 1, 2, and 3. And then we did some of the review in 4 already. So that's crazy. It reviewed 4 chapters in one assignment. Okay, you just got to make sure you keep paying attention to it as you're going. Now, if you're done with this and you don't have anything else to add, great. But if you're not, keep it. But if you are done with it, pass it up, and then get yourself to page 7, because that's where we're going to next. Thanks, kiddo. I'm going to give you this back. I really want you to have it, though. tried to give me a present in class. It was the pen that he uses. It was just a piece of plastic. Okay, so you guys got today's notes. They're ready to rock and roll. Let's look at those things on page 7. Page 7 in your notes. Let's get those things out and rolling. Page 7. If you gave me a retake, or a makeup I should say, for chapter 3, it was placed in your grade during lunch today, so you guys know what's going on with that. It was part of what happened during lunch. So if you've got questions or anything, make sure you know that I've updated those. I don't think anybody in this class had it, so hopefully those other folks know. Pay attention to the markings in the diagrams. They're as important as the words. And I'm trying to shortcut all the jibber-jobby I've got up here, the jibber-jobber. This jibber-jobber comes down to this. And please notice the markings that I have in those two triangles. If you're going to put in angle, side, angle into your notes, I would put in the formation that angle, side, angle is, so you can quickly look at it and get that the congruent angles are created connected to the congruent sides. Okay, the congruent angles are connected to the congruent side. Okay, when I'm talking about angle, side, angle. So I'm trying to shortcut them so we can connect it in our heads what that really looks like. But you have to have the picture. You have to have the markings when you're doing this. And it's a big deal. You guys hear about the optometrist that fell into his lens grinder? You didn't? Well, he made a spectacle out of himself. Hey, I know you're telling that tonight at dinner. I get it. I know that. I know that's happening. And by the way, that's not an original Bloom, by the way. That one's from Happy Days back in the late 70s. Ralph Mouth. Ralph Mouth. We like Ralph. Okay. Angle, angle, side. One congruent angle is not connected to the congruent side. Check it out. This congruent angle is not connected to that side. The other one is. Okay, when I use angle, angle, side, this is the only way I can use it. It's got to be that other angle is just off by itself. Okay, it's not included. Okay, and check out what it looks like to use an angle, side, angle. I want you to compare the two. There's a difference of the two. Okay, it's just not, well, I got two angles at a side, I can use either one. You cannot. You cannot do that. Okay, I want to point that out as soon as we get going on this, because that is a #1 mistake people make. Now, as I'm waiting for other people to finish, problem 1 asks you to determine which triangles are congruent based on angle, side, angle, or angle, angle, side. So if you would go off and start that if you're ready, and as everybody's working on it, I'll recognize it and I'll get my stuff to that page. So you guys are doing problem 1. You guys are doing problem 1 right off the bat. Somebody should actually clean this stuff up so he can explain himself. Now, as we're looking at this problem 1, you've got to keep in mind, I have arrowheads on EF and HJ. That means they're parallel. I also have tick marks. That means they're congruent. So I got parallel and congruent, okay, because of the separate markings. Now, because they're parallel, this angle and this angle are congruent. Because they're parallel, this angle and this angle up here are congruent because they're both sets of alternate interior angles. Because those segments are congruent, I have angle side angle. Are there any questions about that? Did anybody do something else? Did anybody use vertical angles? And people are like, well, what do you mean? It's in a bow tie. There's vertical angles here, right? So here's my thing. I could, with the same information, prove these two triangles angle, angle, side. Because the vertical angle's in one of the alternate interiors. Now, that's the second way I could do this. A third way is the other side, or the other set of alternate interior angles. So there's three ways if I was to approach this proof to complete it. Okay? Now, keep in mind, the more you know, the more skills you have, the more information you attain, the more ways something can be done. Okay? So the further we go on, based on the same given, you could do things a couple different ways. It creates a headache for the instructor because, you know, I have to be ready for grading it those couple, 3 or 4 different ways. All right? So just know that as we're going about it. Okay? Don't let that be a frustration. It should be a friendly thing as we're going because options are good. And B, I have 2 sets of parallel sides with both of these. The reason I'm doing this is I need you to be aware of what angles are congruent with each set of parallel lines provided. So I have MP, let me get a different color because that's not very helpful. I have MP and NQ parallel. Well, I got that transversal going across, and it's this angle and this angle here that are congruent because of those 2 parallel lines. Okay? I have some people going, well, all lines are parallel if you got parallels. No, all angles are congruent if you got parallel lines. No, you got to be careful. Okay? Pay attention that the parallel lines and the transversal sandwich the angles that are congruent between them. Now, the reason why I'm doing it like this is I want to be clear that if I got this one, and this one are congruent to each other because of the greens in the transversal. If the transversal was green, the greens sandwich that angle. Okay, so now I've got angle, side, angle. Do you see angle, side, angle? And this one was that. C, you're on. Check it out. See what you know. You're on with C. A-holes. How'd you do? You okay? Follow-up questions. Okay, again, keep in mind, parallel line, parallel line. This was parallel over here. Remember, that one sandwiches for that one, and that one for that one as I'm going down. So make sure that you see that, okay, as we're going. Now, that's it. That's the new stuff. And now let's use it. Maybe, possibly. You ready? I have, once again, provided you this statement. My perpendicular segments or lines. When I say that, I'm telling you, you got right angles. And when you got right angles, you got all right angles congruent. It's a 2-step process to get to that. But once I do that, I know what's going on. So I'm going to write my given. I get my given down. Okay. And I'm going to look at my diagram. I got my 2-step for my perpendicular segments to get those right angles congruent. So eventually, I can be able to talk about this angle and this angle that are right angles. They're congruent. But if I got 2 angles on the top, on the left and 2 angles on the right along that segment AC. What do I know about AC? Other than the fact you follow it up with DC and you have a real decent band. Okay. What do you know about AC? Somebody said it, I think. Reflexive. Okay, so I got AC, it's congruent to itself. I'm golden, I've got angle side angle. Okay, so I've got my little two-step dance, I got my reflexive, and I got my ABC congruent to ADC triangles because of angle side angle. But every time I do this, it's that dance. I look at what I got, I look at my diagram, I mark up my diagram, I get familiar with it, and I think, I gotta prove triangles. What do I know of my 4 tools today now to help me prove those 2 triangles congruent with the information they gave me, along with the picture? Okay, so you're doing some really good problem solving, troubleshooting. Okay. Check it out. You guys write this one. You guys write this one. See what up. See what up. Okay, see what up. Now, when I'm looking at this, I've got segment QR congruent to segment TS. That's fantastic. It's congruent. But now I'm looking at QRTS. Hey, you know something? They're parallel. Holy cats. I've got alternate interiors. And QT, I got reflexive. So then I've got side angle side. Do you see it? So I got a given, reflexive, alternate interior, side angle side. Or I could have said given, alternate interior angles, reflexive, side angle side. Those are the 2 ways I could write this same proof. Go ahead, get her done. See what up. Remember, as we're doing this, you should be practicing. You've got this, so that's reflexive. You got 2 angles that are going to be alternate interiors. It's that one and that one. And after you get those, you got yourself 2 triangles that are congruent because I've got a side, an angle, and a side all ready to roll. Okay? So give yourself some props if you're getting this written. Okay? But if you're not, please ask questions. We got to clarify these things because there's something that we're missing out on. I understand it, but it's not okay that we just sit and decide that it's not okay to learn about it. Okay, so make sure you're making the connections. And remember, every time I'm writing these angles, the vertex is always the middle of those angles. That vertex of the angle is always the middle. If I do a different one in the middle, I'm talking about a different angle entirely. Now, this one's frustrating for folks. Why in the world did Bloom number 5 of them, but he only used 4 of them? Because I didn't have any need for a 5th one. Okay, I decided not to split my given. Okay, I think on my key I probably put the given on the line 1 and line 2. Okay, so I use 5 lines, but I make it look like this one's smaller. Okay, I put all the given on 1 line. Okay, turn the page after you're done with this and go ahead and do number 14. Number 14. That'll be our last one today. And based on what we've already done, 14 should feel like something we're going to do on the test because it is straightforward. It is asking you to identify some angles because of angle bisector. You're given another angle, and then you're asked, or I should say provided, reflexive property with segments. So we got a lot of stuff going on there that's going to help us get things done. moving on the 14 myself, maybe. How'd you do? Is that direction you're going? Keep in mind, you could have taken step 2 and step 3. I got step 2, definition of angle bisector, and step 3, reflexive. You could have flip-flopped those. Okay, so you got a given definition of angle bisector, reflexive, angle side congruence, or you could have gone given reflexive definition of angle bisector, angle side congruence. Okay, those have been your choices. Now here's the deal. 14 was our last one for today, but keep in mind, I'm choosing to stop here so that way you can have time to work and complete your assignment, being it's Friday, but also ask questions in the last 14 minutes. Okay, a lot of people had some really good work time today and were able to get a lot done. Let's see, I helped 3 people on problem 10, and after that there were 4 problems left. Okay, today as we were going through on my 4th period. So make sure you guys are aware that as we're getting this done, the time provided to you, although I have plenty of material to go through another 15 minutes, I think it's in my best interest and yours to give you work time so you can ask questions and kind of get your mind about what we're covering. If you're not sure about something, I'm pretty confident we've already covered it in the last 2 days of notes. So have your notes open and just double check. Okay. And remember, as we're going, the best thing you can do is ask questions. Okay. And I'm going to do my best to make sure every one of those is answered. Monday, we're just going to do more proofs. See what's going on. So good luck at home. Good luck here. Have a great weekend.